Question 9 asks, how are ionic compounds named? First, I'll write out the definition of ionic compounds. They involve a metal and a non-metal. And it also involves them as ions, since electrons are either given or taken away. So compared to covalent molecules, it involves the sharing of electrons, but in ionic compounds, you have a metal that completely gives away some of its electrons to a non-metal. So that's how the bonds are formed, because you get a positively charged metal and a negatively charged non-metal, and they are attracted to each other. So when you need to name ionic compounds, there are a couple steps. So the first step is just to simply name your cation, which most of the times it's just the metal. Step 2 is name the anion, which is just your non-metal. And then after you name your anion, you want to change its suffix to "ide." Then the last step, it's only applicable to metals that have more than one charge. So we can also add the charge in parentheses. So in Roman numerals. Only if the metal can have multiple charges. Okay, so I'm going to write down an example. So let's say we had to name CuCl. First step is to name the cation. So in this case, it's copper. Second step, name the anion. So it is chlorine, but we are going to change the suffix to "ide." So copper chloride. And then since copper can have multiple charges, in the case of copper chloride, there's only one copper reacting with the chlorine, which has a -1 charge. And since the entire compound is neutral, we know that copper only needs to have a +1 charge to neutralize the chlorine. So I'm just going to put a Roman numeral of 1 in the brackets. So the final ionic compound name is copper 1 chloride. So let's say we had CuCl2. We're going to do the same thing we did earlier, copper chloride. But now notice that for this compound, there are 2 chlorines needed to neutralize the copper. So this shows us that the copper has a +2 charge. So the name of this compound is copper 2 chloride. Okay, so pretty straightforward. The junior tutor said that ionic compounds are made up of a combination of ions. It can be a cation or an anion. The general rules in naming ionic compounds are to identify and name the cation, then the anion. There are different ways of naming them depending on the type of compound. Binary ionic compounds, as the name suggests, means it is a combination of two ions of different elements. One atom is a metal, the other is a nonmetal. It is important to have a knowledge of metallic and non-metallic elements, and this can be easily observed in the periodic table as shown below. Okay, so they show all the different metals and nonmetals. Following the rules and adding a suffix, here are the steps on naming binary compounds. Identify and name the cation, name the anion, and end the suffix to "ide." Yep, so they have some examples. So magnesium oxide, sodium fluoride, potassium sulfide, and calcium phosphide. For binary ionic compounds with transition metals, it is important to determine the correct ion of the metal. Transition metals can form more than one cation. Transition metals are those belonging from groups 3 to 12 of the periodic table. Okay, so they show where all the transition metals are located as well. And then they talk about the different charges you can have. So where you can specify what the charge is by using Roman numerals in the brackets. So what I didn't mention are also polyatomic ions. So these are usually given to you in like a table or a chart. But it's also good to know all of the commonly used polyatomic ions such as carbonate or phosphate and sulfate. So they mention polyatomic ions as well. And these are all of the common polyatomic ions that you can see. So it has the same similar rule as what we talked about already. You name the cation first, and then the anion second. Change the suffix to "ide." However, it can also be a polyatomic anion, so we just use the name of the polyatomic anion specified in the table shown above. So if you had an ammonium ion reacting with a chlorine, you get ammonium chloride. Yep, so this solution is correct.